All right, let's go through solving a rational function. Now, one of the little tricks that we can use, instead of simplifying the addition here to one fraction and cross multiplying, what we can do is find the common denominator first. So the first thing we want to find is a common denominator. And really what you really want to find is what's called the least common denominator. So the smallest common denominator you can, not the largest thing possible, but one of the smallest ones. If you notice, in common, we have an n in common in two of the terms. The other terms, we have a 5 in common. So what we could do is we could combine those two, and we could say, would a common denominator of 5n work? Well, let's check it. But before we do, I'm going to go ahead and make some highlighted dots and write down 5n each time and see what happens. In other words, if I multiply each one of these terms by a least common denominator of 5n, will it remove all of my denominators? Will it cancel out each one of the denominators? Could leave something left over, but will it cancel out the denominator? That's the goal. Well, 5 times n times 3, the n's would cancel out. 5n times 1 over 5n, the 5's would cancel out, and the n's will cancel out. And the 5n times 1 over 5, the 5's cancel out. Now, if we look at the problem, I have scratched out all of my denominators. So now I have no more denominators, no more fractions to work out the problem. Now, what do I have up in the numerator? I have 5 times 3. I have 1. And I have the n times 1. So now I just work out the algebraic problem. 5 times 3 is 15, plus 1, n times 1 is n. And that's not plus there, is 15 equals. I need to subtract 1 on each side of the equal sign so that I have my n by itself. 15 minus 1 is 14. 1 minus 1 gives me 0. 0 plus n is n. Let's look at another problem to work through to cancel out our denominators. Remember, that's our goal here. We want to cancel out all of those denominators using our least common denominator. So looking at our denominators here, 3n, 3, and 2n, what is the least common denominator? So out of a 3n, a 3, and a 2n, what's the least thing I can make here? Now, like I did before, let's look at it kind of visually a little bit. We have a 3 in common in 2 terms. The other 2 terms have an n in common, but I have this 2 that's not in common with anything. So what we're going to do, since we have the n's in common, we definitely want to have an n. Since 2 and 3 are not in common, what we're going to do is we're going to take 3 times 2 then and get 6. Because I know 6 divided by 3 will give me 2, and 6 divided by 2 is going to give me 3. So what I'm going to do is I'm going to multiply each one of my terms above in my equation up here. I'm going to multiply this entire equation by 6n. I'm going to take 6n times 2 over 3n equals 6n times 1/3 minus 6n times 5/2n. Now I rewrote what I had above so that when I start canceling out and simplifying terms, you can see what we started with above. So if you notice, in the first term, my n's are going to cancel out. 6 divided by 3 can be simplified down. Both of them can be divided by 3. 6 divided by 3 is 2. 3 divided by 3 is 1. And my next term, nothing cancels out directly. However, we can look again at 6 and 3. 6 and 3 can both be divided by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. My next term, my n's, cancel out top and bottom, and my 6 divided by 2 will simplify. Both of them can be divided by 2. 6 divided by 2 is 3, and 2 divided by 2 is 1. Now, you could say, well, I have 1 in all the denominators, but remember, anything over 1 leaves you with just what's in the numerator. So let's write out our numerators. We have 2 times 2. So we have, let me go ahead and write that out for you. So you have 2 times 2. And we have the 2, the n, and the 1 left over. And then we have the 3 times 5. So 2 times 2 is 4. 2 times n times 1 is 2n. And 3 times 5 is 15. I'm going to add 15 to the other side so I can have just the 2n. So 4 plus 15 is 19 equals 2n because negative 15 and 15 gives me 0. Then I'm going to divide each side by 2. And 19 halves equals n, or 19/2. All right, let's look at number 3. And our third problem here, if we notice, we have denominators that, 2 denominators that's a trinomial, and 1 denominator here that's a binomial. Well, when you have a trinomial, we need to look for our GCF, and we need to factor down the problem. We have x minus 4. We hope that the x squared plus x minus 4 has a factor of x minus 4. That would be really nice for our common, at least common denominators. So let's go ahead and factor x squared plus x minus 20. Now remember, when we factor, we want to find out what 2 numbers are going to multiply to give me a negative 20, and what 2 numbers are going to add to give me the coefficient out here in front of x, which would be 1. When we look at the numbers that would work, negative 4 times 5 multiplies to give us negative 20, and negative 4 plus 5 adds to 1. So then we have x squared minus 4x plus 5x minus 20. Out of the first 2 terms, I can factor out an x, and I have an x minus 4. Out of the next 2 terms, I can factor out a 5, which will give me x minus 4 again. So my factors are x plus 5 and x minus 4. So I'm going to rewrite the problem that I was given and write my trinomials into the factors. Now I'm just going to erase the 6 and make my handwriting a little bit neater. Now I recopied my problem so that when I highlight, we can see what I wrote originally and then what I'm highlighting here. So my denominators, I'm going to highlight my common factors to see what I have in common and what I do not have in common. I notice that each one of my terms has an x minus 4, but two terms have an x plus 5. So my least common denominator is going to be the yellow and the blue. It's going to be the two factors I have, the yellow factor and the blue factor, that I want to multiply each term by. So the x plus 5 and the x minus 4 being multiplied to each one of the terms. So what we want to do is take the x plus 5 and x minus 4s and multiply it to each of the terms So when I do that, what's going to cancel out? My x plus 5s cancel, and my x minus 4s cancel. X plus 5s cancel, x minus 4s cancel. And my last term, only the x minus 4s cancel, and that's okay because I've scratched out all of my denominators. That's the goal. So let's write what I have left over. I have the 4 equals 6 plus, I have the x plus 5, and that's being multiplied times 1. So we have 4 equals 6 plus, distributing out the 1, I'm left with x plus 5. 4 equals 6 plus 5 is 11. So now I need to subtract 11 on each side. So x is going to equal negative 7. All right, let's look at our fourth example problem. Again, if we notice two of our denominators are binomials, so we need to look at the GCF and we need to look to factor them. Okay, so I'm going to write that out here to the side, 3n squared minus 15n. We notice 3 and 15 both have a 3 in common, and they both have the variable n in common. So we can take the GCF of 3n, and what we're left over, 3 divided by 3 is 1, and n squared means it's n times n. One of the n's will cancel out, leaving us just with an n. 15 divided by 3 is 5, and the n's cancel out. So I'm going to rewrite my problem now as 2 over 3n plus 4. And instead of writing what I have here, I'm going to write the GCF factored out, and 3n minus 5. And then again, 3n n minus 5. If it helps visually, highlight what you have in common. Each of the terms have a 3n, so great. I can multiply every single term by a 3n, and I can get rid of my 3n's all the way across. Now, if we notice, two terms, though, have the n minus 5. So I'm also going to have to put up here the n minus 5, so that when I multiply it times these two terms, both of my denominators will cancel out on both of them. So taking 3n n minus 5 times 2 over 3n plus 3n n minus 5 times 4 over 3n n minus 5 equals 3n times n minus 5 times n minus 3 over 3n n minus 5. All right, let's cancel out what's in common in the numerator and denominator. The 3n's will cancel out. And the next term, the 3n's and the n minus 5's cancel out. And the last term, the 3n's and the n minus 5's cancel out. What I want to check is down here in the numerators that, or sorry, down here in the denominators, that all of our denominators canceled out. We're not worried about what's left over in the numerator. So now I have n minus 5 times 2 plus 4 is all that I have left, and then the n minus 3. Distribute out my 2, and I'm left with 2n minus 10 plus 4 equals n minus 3. I'm going to combine my like terms of negative 10 and 4. They're on the same side of the equal sign, so I'm just going to combine them as I see them. So I'm going to have 2n minus 6 equals n minus 3. Now, because of the equal sign, I want to combine my n's. 2n minus n gives me n minus 6 equals, now I have n minus n is 0. 0 minus 3 is negative 3. Add 6 so that I have now n plus 0, because negative 6 plus 6 gives me 0, so I'm just left with n, and negative 3 plus 6 is 3. Now go ahead and copy this problem down. We're going to talk about some function notation with our rationals. So how would it look if we had f of x and g of x representing a rational function, and then we have an operation with it? All right, I'm going to use a highlighter and highlight to help see what's happening visually. So I have f of x. So what I want to do is substitute in what f of x equals here. F of x is 4a minus 6 divided by 9a minus 54. My g of x is a minus 6 divided by 9a minus 54. And again, that's going to substitute in here for my g function. So a minus 6 divided by 9a minus 54. Now in red, I'm going to highlight that these two rational expressions are being subtracted. So we have subtraction. Remember, with subtraction, we need common denominators. So what we want is 4a minus 6, 9a minus 54, minus a minus 6, 9a minus 54. Rewriting so I have more room to work out the problem for you. We notice our denominators are already the same, correct? So since they're the same, I can just go ahead and work out my numerators. I can go ahead and take my numerators with the sign. Now remember, it's a minus sign, so I must distribute that minus sign to each term to its right. There's nothing to distribute to the 4a minus 6, so it just stays 4a minus 6. When I distribute a negative times a positive is a negative, so I'll have a negative a. And negative times a negative makes a positive, so I'll have plus 6. My denominators are the same, so I write it down one time. Four a minus a is 3a, and negative 6 plus 6 is 0 over 9a minus 54. Now, before you say, oh, I'm done, we have one more step. We need to simplify our binomials and our trinomials. So if we simplify 9a minus 54, I can divide 9 and 54 by a 9, and then I have a minus 6. So I have 3a over 9a minus 6. I did this because now I have 3 and 9, and 3 and 9 can simplify. They're both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So now I have my most simplified answer of a and 3a minus 6. Now let's look at a second example problem. Pay attention this time. We have a plus sign, so it's f of x plus g of x. All right, let's substitute what f of x is. F of x is 6r. And then we have 2r minus 10 plus my g of x, and that is 2/3. Well, I have a plus sign, so I have addition. So when we have addition, remember, we need common denominators. Big hint, put your binomial in parentheses. Now we notice that I need to multiply the 3 times the 2r minus 10. I need to multiply the 2r minus 10 by 3. And now, yes, I have common denominators. But what I multiply in the denominator, I also have to multiply up on the numerator for each fraction. So I have 2r minus 10 in both of my denominators now. In my numerator, I have 3 times 6r, which is 18r. And I need to distribute the 2 to both the 2r and the negative 10, so I'm going to have 4r minus 20. I have common denominator, so I can write it down one time. Then I can take the plus sign, and that plus sign is distributed to both terms in the next numerator. So I have 18r plus times a plus, positive times a positive stays a positive, so we have plus 4r, and positive times a negative stays a negative. I need to combine my like terms in my numerator. 18r and 4r is 22r, and then minus 20 over 3, 2r minus 10. We need to check and simplify. (22r minus 20) does have a GCF in it. 22 and 20 can both be divided by 2. So you'd have 2 and 11r minus 20. Let me change that for a second. 20 divided by 2 is not 20. 20 divided by 2 is 10. Now, don't let your eyes trick you. That's 11r minus 10 and 2r minus 10. They cannot be canceled out. So on a test, if it was multiple choice, you'd have to see which one of these two answers was in the answer choices.